Good Monday morning to you, fellas. Glad you tuned in and hope you get something out of this. I had fun putting it together. I was going to tell you about some customer caused concerns, and there's some other stories here that weren't customer caused, but customers sometimes can cause themselves problems. I was chatting with a guy on one of the pages that I'm on Facebook. He was talking about how a lot of the times he has to go back and undo what some customer did to their car before he can go back in there and fix it the right way. And I've run into that same thing when I was working on stuff that other people had tried to fix themselves, you know. Of course, some people do a pretty good job fixing their own stuff, so I'm not hating on all the DIY people, you know, but bear with me there. This Mustang, I had 11,008 miles on it whenever I encountered it. And the concern was it was surging. Now, one of the things that a lot of vehicles would surge and customers wouldn't notice them surging. And also, one of the things that's very annoying to try to work out of one, back in some of the earlier days of emission controls, is to make one stop surging. And a lot of times it's EGR related, and I'll talk about that in a minute. But once there was a transmission mechanic that drove a car with a customer about some kind of a transmission concern, and totally unrelated to it, he told the guy that the car was surging and he needed to have it fixed. And I really didn't appreciate that, because working on a surge can be a pain. I think there's quite a few things that can make them surge, but this one here, it did have a surge at road speed that would evaporate though when you disconnected the EGR. And this was not one of the ones that had all the little ports like I was talking about last week, and it didn't have a misfire code per se. But some of the vehicles with torque converter modulation, you know, and that's been around since the late 80s, where they didn't just lock the torque converter in all the way, they would modulate it a percentage on the way up. First time I ran into that was on a 89 Eagle Summit, because we had the franchise for them. And this vehicle was brand new, and they noticed that they didn't feel a surge, but they noticed the tachometer doing it. And what was so crazy about that was when I was first working on it, you know, I eliminated all the obvious stuff, and I just cleaned the injectors, and that took care of it. A couple of days later, they were back with the same problem. So I swapped out the injectors and put a set in there from another brand new vehicle. That took care of it. 2 days later, they were back again, and it turned out that what was causing that one was the transmission fluid did not have friction modifier in it. Now, I had connected a dwell meter to the torque converter clutch line, and I had noticed that the waggling on the tack that I was seeing was lined up with that torque converter modulation. And when I called down there to New Orleans and talked to that field service engineer, he told me to get Mopar Plus transmission fluid put in it. And I thought that was a bunch of hooey, but when I changed out the transmission fluid, that took care of that surge permanently. And after that, I saw another vehicle that was an Eagle Talon, I think, that had a surge, because our transmission mechanic had serviced the transmission and put the wrong kind of transmission fluid in it. And they had given it to me for a surge that didn't happen until after he serviced the transmission. But I had also seen that on some Ford Tauruses. One time I worked on a Ford Taurus, and I realized that when I had the flight recorder or whatever from SBDS on it, that the surge I was feeling was related to torque converter modulation, the percentage of it. And when it was 100% locked up, I didn't see that. But whenever it was like 50%, I'd feel the surge. And so, based on what I had learned about that Eagle Summit, I got some friction modifier like you put in these limited slip differentials, and I poured a little bit of that in the transmission and took care of that. And after that, the fluid they were coming out with that had the friction modifier in it would smell a lot like that friction modifier that you put in the rear end. Anyway, that's another, I got off on a tangent, sorry about that. This is the EGR system in general. Now, this is just a general EGR system thing. And what you got is, when this valve is opened by this electronic solenoid, this is a computer controlling this solenoid. See, this actually represents the computer, and it's controlling the solenoid. it delivers modulated engine vacuum to the EGR valve to open it. Now, some of the Asian platforms will have an EGR temperature sensor down under here. That's kind of rare on America. I've never seen it on an American car, I don't think. But about 5% of the exhaust on average is recycled, and they run it in here and it displaces some of the burnable mix so that the combustion chamber runs a little cooler so it does not form oxides of nitrogen. If you keep it below 2,500 degrees Fahrenheit, it doesn't form oxides of nitrogen nearly as bad. So what's left over that is formed goes out of here through the catalyst. Now, some people, if you say, what's EGR? They say, well, it reburns some of the exhaust gas. Well, no, this is already inert because there's nothing in it. Whenever people down in the oil patch country where I worked on the coast for 5 years, when they were having to cut a drum with a torch, and that drum had some kind of flammable whatever in it, what they would do is take the exhaust pipe. They would take a tube and put it on the exhaust pipe of a vehicle and run that pipe into that drum and let it run long enough to fill that drum up with inert gas that would not explode. There would be no oxygen in there. It would push it all out, and then they could cut it with a torch without it blowing up in their face. I mean, I knew of them doing that, but I never was all that comfortable with that, although what they were doing was similar to what the EGR is doing. It's basically displacing some of the burnable mix. If you're watching the oxygen sensor, when the EGR starts to flow, you'll see it drift in the rich direction because there's less oxygen whenever you've displaced some of it with this exhaust. Okay. Well, the Mustang's EGR system, the EGR valve here, I used to get really irritated with some of my students because I would ask them where the EGR valve is and they'd point to the fuel pressure regulator because they thought that was the same thing without even paying attention to the fact that it was on the fuel rail. Anyway, this is the EGR valve. This is the DPFE sensor. These metal DPFE sensors had a voltage at rest of 0.6 of a volt. The plastic ones, like you see in my illustration here, would have a 1 volt at rest voltage. But basically it's got reference voltage, and it's got a signal return ground, and then it's got a signal wire, and that's what goes out and gives it the feedback to PCM. This is the Ford system. There's an orifice right here, and when you run something flowing past an orifice, the pressure increases on this side of the orifice, and it decreases over here. There were actually some trouble codes you could get on some of the Fords that would say that when these hoses were reversed, even though they were two different sizes, people could manage to reverse them. If you reverse those hoses, it would say they were reversed because it could pick up on that. Some of the codes. It compared the pressure differential, and this would go up, up to like 4.6 volts, depending on how much EGR was flowing. But there's always an optimum amount of EGR. Before we had this DPFE sensor, which came out in 1991 on Lincoln's, on the 4.6, they basically had these little washers that you would stake into the bottom of the EGR valve that would determine how much EGR was flowing. If you had one that was surging, you could take the EGR valve off and replace that little washer with one that was smaller so you weren't flowing as much EGR and it wouldn't surge. Of course, the older ones that had the two solenoids operating the EGR, those solenoids would go bad and it would make it, buck and surge and all that. But anyway, you get power from the EEC power relay, and the PCM would operate this, and then it gets it. This is a feedback loop, basically. It's basically watching that. That's right there. If I do a circle, that's a feedback loop. And you can kind of study that and pay attention to it a little bit later if you want to. Well, this is what we saw on the scan tool on this particular Mustang. Of course, that barometric pressure right there looks a little bit low for this sea level area where we are, but a lot of those barometric pressure, the mass airflow system would read a barometric pressure of 153 hertz for some reason. I don't know why. 159 was what the map sensor would read on one of these Fords for sea level pressure. DPF EGR, this right here is what that EGR was reading when you were driving. And there's your engine coolant temperature is 100. So EGR vacuum regulator was rocking along at about 70%. And so, of course, this right here and this are tied together. And so it didn't really look like there was all that much too much EGR. This was about the right amount of EGR, so why was it surging? That's what we were looking at. But I told my buddy, and he was the primary guy working on this, I said, you remember those old 3.8 liter CFI engines, central fuel injection, had 2 injectors in the throttle body, that would develop a surge that would go away when the EGR was unplugged. Then you'd pull the spark plugs out and they have this puffy brown oil consumption hard stuff on it from leaking valve stem seals. Anytime you see that puffy brown stuff on those plugs, it's valve stem seals that's causing it. Chevrolets are bad to do this, some of the 350s were. The problem on those cars was the spark plugs and the valve stem seal deposits, not the EGR. And we were talking about that. And this is what those deposits look like. You see these old puffy deposits, that's valve stem seal problems, leaking valve stem seals. Shut off the engine. On some of the, whichever valves are open, they'll get a little bit of oil on the plug and it just kind of sits there. Not enough to foul the plug completely where it won't fire. But when you fire it up, it cooks that, and it keeps doing that until it builds up, and this is actually oil that has been cooked to the point to where it's actually, and you try to chip this stuff off, it's really hard. It's not as soft as it looks. And this can cause surges and random misfires even when there's nothing wrong with the EGR. The EGR exacerbates it, but the EGR is not the problem, so you got to be careful with that too. My brother's 71 Thunderbird, and this was a cream puff of a car that he paid $1,700 for in the, I think he bought it in like 1983 or something. But anyway, it was a beautiful, beautiful car, and it had one of those it was the only Thunderbird that had the high horsepower 429 in it. But anyway, it had a 350 horsepower or something. It was a huge amount of horsepower that one had. And the other ones that came before and after it didn't have that much horsepower. This one did. Anyway, this had this rusty red stuff, and the plugs were brand new. And he said, it's surging and cutting out. So I pulled it out and saw this junk on there, this red powdery, rusty looking red powder. And he told me he had been using octane booster, and I says, oh really? See, I'm backed up into that experience, and I says, let's pull the spark plugs out of this brand new Mustang practically and see what we see. Well, when we pull the plugs out, this is what we saw. Those old rusty stuff. Found out, we asked the guy, he said, oh yeah, I've been using octane booster, but this is one of the plugs from that car, and you see how the sparks were literally jumping to the side instead of jumping across here, because that octane booster puts this stuff on here, and that red stuff is conductive, so that it makes it a little bit easier for the spark to go places it's not supposed to go, and that keeps the plug from firing the mix like it's supposed to. I don't know if you've ever noticed when if somebody puts a set of spark plugs in a vehicle and they've got the spark plugs gapped a little bit too close, you'll notice it. Well, I say a little bit too close. In some of the vans that Ford made, they would say they wanted the plugs to be gapped at 42 thousandths of an inch. And my buddy Donnie came to work from Lincoln Mercury place up there to the Ford, and he didn't work on a lot of vans at Lincoln Mercury. And I says, he was putting plugs in his van. I said, you better gap those plugs at 50 thousandths of an inch, or you're going to be pulling them back out of there when it don't idle right. Because when those plugs are gapped a little too close, or when one's almost fouled, it'll go poo, 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 poo. Whenever it's doing that, you either got a plug that's partially fouled, or somebody's got one that's gapped too close. And so I took he says, no, I'm going by what this sticker says, and I don't care what you say. Well, whenever he fired it up, he was listening to it idle, and he had to pull all the plugs back out and spread the gap out to about 50,000. So that was kind of funny. I tried to warn him though, and he wouldn't pay any attention. He had the idea that and Tempos, when they first came out, they had a gap that was on the sticker that was too close, and Ford had us pull all of the plugs out of those and gap them a little bit wider. And that's one of the reasons that I drew on that. Well, this F-150, 11,000 miles. It was nearly new at the time, and it had an intermittent misfire bite under load. Actually, it had a few more miles than that. I think I left the miles from the Mustang when I copied that clipboard, but it was a low mileage vehicle, as long and short of it was. And so at the Advanced Engine Performance School down there, they showed this slide on one of the training courses we were supposed to go through while we were in Advanced Engine Performance. You notice that says 8,000 ohms. And that's basically was pretty much, it's supposed to have less than 10,000 is what the course material said. I showed this to some people on one of the automotive web pages, Facebook pages I'm on, and some guy said, oh no, that's an antiquated test, it doesn't mean anything. And I was thinking, a lot of the times we're closed-minded enough to where if we've never used a test that somebody else is using, we try to reject it out of hand like we know everything about everything. I've always been trying to be open-minded enough, like when I was doing rear brakes on a car, on a vehicle. Everybody's got their own way of putting brake shoes on. And I'd be putting the brake shoes on, and somebody would walk by inevitably and they say, hey, I do that a different way than what you do it. And I would say, well, really, how do you do it? And I'd step out of the way and watch them do my work. And they would show me, and if I liked their way of doing it better than the way I did it, I would start doing it their way. And I found the best way to do it over time by watching how other people did it when they volunteered to show me how to put rear brakes on. Anyway, it was just kind of funny. So this one here, IDS power balance pinpointed the misfire at number 7. And most plugs will measure between 3,000 and 6,000 ohms and won't vary much from plug to plug. That's what I found out. You can play around with this. Now, I will tell you that you're going to have to scratch this really good with your meter and scratch that really good with your meter so you'll get a good connection so you're measuring that center electrode. And there's really nothing wrong with it. Some of the mechanics on that page that I would put this on said that they measure the resistance of the plugs too. The Champion spark plugs people, one guy when I published this in a Motor's Age article sent me an ugly letter that said you're never supposed to do that, but Champion spark plugs measure all over the place when I've measured them. They'll measure 2,000 to 17,000 and everywhere in between. I don't know. I'm not hating on Champion plugs once again, but we've talked about this a little bit before. This Super Crew had an inoperative rear entertainment system. Now this was back in the days whenever some of the vehicles came with VCRs. Now VCRs are basically, some people nowadays don't even know what a CD is when you're talking about music because they're so used to MP3s and all this. But this particular system wouldn't activate. At the time this was a big deal because this vehicle was brand new, and so I had to figure out why that screen in the back wouldn't wake up. Well, these Ford audio systems with multiple control panels have a circuit called, and if they had a CD player in them, ASYS ON, audio system on, it's a single wire that activates remote modules and control panels as soon as the driver turns on the radio. It's just that one wire. You turn on the radio, this thing fires up and it goes to all of these control panels. Everything that's supposed to be connected to the radio wakes up as soon as it sees this. And this was going through connector C275, and that is the pinout of that connector that it was going through. Alright, so I said, well, I need to have a look at this. It was basically what you need to do when you're tracking a situation like this is you need to go to the connector on the circuit that's easiest to get to. I'm a sort of a sequential person, and I like to walk from one connector to the next on the circuit. That's not the smart way to do it. If there's 3 connectors under the dash that are hard to get to and one under the hood that's easy to get to, you start by going to the one under the hood, and then you figure out on which side of it that is. And you may have to go under the dash, but start out at the easiest connector to access. Make sure you know which pin is which, so you'll know what you're looking at when you pull it apart, and see if you see water in there or anything like that. And so anyway, this is what we found on this one. Bent pins. See these bent pins here? When they plugged that thing together on the assembly line, they rocked it together or something. And when they did that, they bent a bunch of pins, and one of these was the wire that turned on the system, the ASYS ON wire. And so that took care of that. And that was that roof-mounted TV, and then see video cassette player is what VCP stood for, and that's actual pictures of that vehicle and actual picture of that connector and all. Well, this one here was a 626 with a 2.5, had a lot of miles on it, ran rough after the starter was replaced, and now it won't start. Now they had replaced the starter with a salvage yard unit that they bought from the junkyard because the original starter had failed. The salvage yard unit starter didn't last very long before it failed. I said, well, it was just probably an old half worn out starter anyway. And so we replaced the starter with one from the parts store, And while we were still doing the rest of our diagnosis, the starter we replaced from the parts store failed. Started spinning really slow, like there was something bad wrong with it and all. And I thought, what the heck is going on here? This is going to be the third starter. First starter died possibly because of age. Second starter died really quick. And this one here from the parts store shouldn't have died this quick. Bench test this here starter. All right, give it some juice. Hear that? Good strong battery and a really lousy starter. Now compare it to a new one. Big difference in those two starters. That first starter in that video was the one that we first put on from the parts store, and it died. And then the second one that we were testing was the new one before we ever put it on there. We needed to find out what the reason was for this starter going bad as fast as it did, and it didn't take very long. Well, what we found out was, you know, you got all of this stuff in that starter circuit. Of course, you got the battery, and this one's hooked to here, and then the ignition switch is basically, you got a, you know, cutout relay, and then you got your neutral safety switch and all that. And so what the long and the short of it was, between, you see this terminal right here, this little terminal, when you're going to bench test the starter, you ground this, and you put hot right here, and then you jump the hot right here, and it kicks in like you saw on the video, right? Well, what the deal was, the voltage that's coming to here, this thing is actually, and I've talked about this before, is a contactor. And when you energize this, these coils slap this contact from here to here, and that carries battery power down to the brushes and spins the starter. Well, the problem was, when this switch, this goes through the transactional range sensor and all that, you know, of course that relay's in there too if you want to look up the schematic. That son of a gun was dropping voltage, meaning that it wasn't getting, it got enough voltage to pull this in, but it was pulling it in very slowly instead of snapping it together like it should have been done. I mean, it ought to be like a contactor. You know, contactors, anybody knows what a contactor is, like on some of these electric or hybrid vehicles or in an outside air conditioning unit. That contactor smacks those terminals together because there's a lot of current flowing through there. You can't engage that slowly, because if you do, it starts to burn and scorch these points here, I mean these contact points, and it gets to where it's dropping voltage here, and so you wound up with voltage dropping going into the starter, and you wound up with not enough voltage here, and low voltage will burn up a starter, and that's what was going on here. It all went back to voltage drop here. Now, as I remember, rather than, this car was a barn car with nearly 200,000 miles on it. The guy just wanted it where he could drive it. I says, rather than swapping out a bunch of switches along here, let's have it where you can turn on the ignition switch, and we've wired it up so that he could push a button and spin the starter. He actually opted for us to fix it that way, and that's what we did. And all those problems went away. You could tell immediately a difference in the way that the thing spun when we did that. So we managed to fix that by bypassing whatever voltage drop was on this circuit here, which is the circuit that, you know, comes through here to that. So anyway, I hope that helped out. I mean, that's not something you often think about. You don't often think about voltage drop here causing voltage drop here inside the solenoid. So there was a problem out here that caused this right here to go bad. Anyway, I hope that was clear. That same one, we pulled the pump out of the tank. It was running kind of crappy, and you could tell the fuel pressure wasn't what it should have been. And this is what we found when we pulled. This is a photo of the pump that came out of that vehicle, and we put a new pump in it and cleaned the gas tank. And we took the gas tank out, put it out there, and, you know, steamed it out and all that. Now, if it's a steel gas tank, you may have some issues with rust that's so bad that the tank may start leaking or something like that. But if it's a plastic gas tank, as I remember this one was, we were able to get that cleaned out and get that going. Now, there's right here is an unmarked 2001 Impala cop car. Now, This was not very many years ago, and they had this older Impala that they probably had impounded from somebody, and they put lights and siren in it and all that, made it into a cop car. And they had run into a situation where the stupid thing wouldn't start sometimes. They had put a battery in it, and they wondered if it was a security/anti-theft problem, and they didn't want to take it to the dealer because the dealer, they felt like, would charge them lots and lots and lots of money chasing the problem. And so I was asked if I would have a look at this on behalf of the Alabama Highway Patrol. I said, sure, I'll look at it. So they brought it in there, and the fixed operations manager brought it to me, or whatever he was, whatever his auxiliary services director, I think is what his title was. And so we actually did some troubleshooting on this one here, and we found out, we checked at a voltage drop test, but from the battery to the big post on the starter with the key in start position trying to start it, we were dropping 7 volts between here and here, which was absolutely ridiculous. And so what we wound up with, what we found on this one, and that's the only thing we did to it, was we did a voltage drop test when it acted up. And this chalk, they had actually replaced the battery, but this is a photo of the actual battery terminal on there. See all that chalky junk? And I took that cable off of there and kept it for an object lesson to show my students. And we got a brand new cable and tailored it so that it was just like this one, just shortened it and put, the eyelet on the end of it so that it was basically a straight replacement for the original cable. But when you're looking at one of these from out here, you cannot see what's in here. And what they did was they screwed that out, pulled it back, put the battery in there, tightened it back up, and they still had all this stuff that was dropping their voltage, you see. And occasionally it would start, and that confused them even more, and they thought it had something to do with anti-theft, because that was fairly common on those cars. You'd have to replace the ignition switch on them for that. And, okay, this one here, the 97 Accord, was driven until it would no longer stop. Usually people drive one until it no longer will go. This one they drove until it no longer stopped. And it was a high mileage, junky, second-rate car. That was this, or car that they didn't drive, well, except when they didn't have nothing else to drive. They had worn the brakes down. Look at that. It blew a caliper and all kinds of stuff. And there's no telling it, but it was a mess. Basically, it was a mess. Now, you might remember, and I don't remember if I've showed pictures like this before, there was a situation where and it's a long story, but this student got in a Bronco that somebody had disconnected the brake pedal on and managed to get it in drive instead of reverse, and he drove forward and knocked this car off the lift. And it kind of bent the fender. When I called the woman and said, hey, we bent the fender on this, knocked it off the lift. She said, I don't care. It's just a junky old car. I don't drive much anyway. She didn't care if it was bent or not. I thought that was interesting. The trainer truck, the Bronco that was a trainer vehicle, is the one that he knocked it off with. I may have shown a picture of that on here before, but if not, I'll put one on there another time. This one here has sagging air springs. Now, anytime you got sagging air springs on one of these Crown Victorias or Lincolns or something like that, the smartest thing you can do is buy the kit they sell at the parts store that comes with springs and shocks, and just put coil springs and shocks on there. And if you're slick, you can actually fix it so that you don't get an air suspension light, or if you don't care, you can just let the air suspension light burn or disable it or whatever. But what we managed to do on this one was we put a set of shocks and springs on it that we bought, that's a kit for this, to do away with the silly air suspension, because those airbags are going to start leaking just like tires that get really old after a long time, and it's really annoying to deal with that. Now, we had this other expedition that belonged to the same guy, and the first time that this guy Bobby pulled these spark plugs out, he tried to screw them out of there real slow, and they came apart. The end comes off the plug, and it just is a mess, and you got a special tool that you got to go down there and you got to screw that in there and use it, and you got to pull it out of there with a special tool one way or another. Now, that tool cost about $100 at the time that I bought it. You can't use it all that many times, because these threads that bite into this shell that you're going to pull out of there, they get to where they're worn down, so you may have to buy another tool. But anyway, he used some JB weld to manage to get one shell out of there. long and short of it is, when we used an impact wrench on all the ones after this, we didn't have any trouble. Another guy was taking plugs out of one of these, and he says, well, I don't want to use an impact wrench on that one in the back because it's too hard to get on. So he screwed it out of there slowly, and the end came off of it, just like I told him not to do. So he had to get the tool, go down there and pull that thing out. This coolant leak on this Chevy Suburban was obvious all over the place, that rusty mess over here. And the JB welder had been there trying to fix that because this fitting, this heater hose fitting, broke off. And so they just JB welded the crud out of this, and they figured more JB weld is better. You hear these people talking about how they built a piston out of JB weld and drove it to Mars and all this kind of stuff. They have all kinds of JB weld stories out there. And I'm not hating on JB weld, I've used it myself. But for something like this, it depends on coolant and not to leak. You don't need to use JB weld on that if you can help it, if there's any other way. So anyway, what we wound up doing was we chipped this out of there, and we tapped it out with a 1/2-inch pipe tap, and then we put a fitting in there and we fixed it the right way. And that's what should have been done to start with, but there was somebody trying to quick fix it, and we didn't go to the trouble to get all that JB weld out of the way, as bad as I hated it being there. As long as it wasn't hurting anything, we just left it alone. Now this was another one, that big old heater pipe that's got the electric water pump in it on these Nissan Pathfinders. I saw that somebody else had fixed one like this, and they put a fitting in there where it had busted off. This thing gets brittle when it gets hot, and if you're working over in that area, you can break that thing, and you're really supposed to replace the entire hose assembly that's like $200 that goes around the the engine bay and all that stuff. And what we did was I took a 1/2-inch pipe tap, and we tapped into this fitting here because it was beefy enough to handle it. There was plenty of plastic there for those threads, and I made pipe threads, and I put Teflon tape on it, and I got this fitting that the hose could go on from, and I screwed that in there, and we fixed that without having to replace that whole hose assembly. I kind of felt bad because one of my people broke it, but anybody can, if you lean on that thing or touch it at all, you're going to bust it. That's just all there is to it. On these Nissan Pathfinders that have that assembly on it with that it's an electric water pump that helps the heater core get flow some kind of way. I didn't think it, but we have replaced that on a different one, but on this one here we fixed it instead of replacing it. This is where I worked in 1977 at Davis Auto Service and carburetor there. I hope you have a great week though. Thanks for watching, and let's all be careful out there. And I'll see you next time.